Name the rigid motion that maps figure S onto figure S prime. Recall, these are the translations, rotations, or reflections. So you're going to choose which rigid motion moves the original figure S onto its new position at S prime. Translation, rotation, or reflection. Here we need to decide which one does not belong. So in A, C, and D, the images are all the same size. In A, we had a translation. In C, we had a reflection over this vertical line. And in D, we had a rotation. But in part B, the image is larger than the original figure. So B is the one that does not belong. So the size of the image does not match the original triangle, or the original, what's that, 1, 2, 3, 4, 5, it's a pentagon, not a triangle. In this slide, it's just a slide that represents the votes from your classmates. So since I'm the only one who has done this activity, there's a 1 here for B. What do you think a dilation does? So here's one that says these are dilations and these are not dilations. So in this one, it got larger and larger. But in this one, it shrunk. And in this one, it got smaller. All the ones that say these are not dilations stay the same size. So it appears that a dilation changes the size of the original shape. In 7th grade, we learned about scale factors. So these look like scale drawings of the original. It doesn't always make it bigger. In these two, it got bigger, but in these two, it was smaller. If you had to use one word to describe what you see in all 4 animations, what would it be? So we can't use rigid motion, well, because that's 2 words, but also this one is not a rigid motion because rigid motion maintains the size of the shape. And we can't say dilation because only this one was dilated. We are going to call these transformations. And the reason that we're going to call it transformations is because rigid motion wouldn't work and dilation wouldn't work, but a transformation changes some aspect of the original. And here it says a rigid motion is the result of any movement of the plane in which the distance between any 2 points stays the same. So the size stays the same. A transformation is a rule that maps each point of the plane to a unique point in the plane. So here we get to sort them. This one says not rigid motions. These ones will be rigid motions. So rigid motions, they stay the same size. Oops. This one is not rigid motions because it changes the size. not rigid motion. This one is the same size. So it's getting really tiny here. Let's see if I can keep it bigger. So not rigid motion. Either it's not the same shape or it's not the same size. But rigid motions are the same size and the same shape. We have two more. This one is not a rigid motion because it's not the same size. And this one is a rigid motion. So now we look at some more on transformations. These look like the same cards. Basically, in this slide, we're going to check and see that our students have the correct answers in these as a whole class. But since we just did it together, we're going to move on. It says, sort the dilations into groups of your choosing. So I see A was smaller, B was larger, C is larger, D is smaller, E is larger, F is smaller, and G is smaller. So I might sort them based on what's called an enlargement versus a reduction. Those are words we heard back in 7th grade. An enlargement makes it larger than the original, and a reduction would make it smaller than the original. So A, I'm going to put in the reduction. B is an enlargement. C is also an enlargement. D was a reduction. E is an enlargement. F was a reduction. And G was a reduction. You can see that the blue is smaller than the original dashed triangle. Again, this is just for us to check our work with a whole group. All right, it says move the center of dilation. The center of dilation is this point O here. What happens to the image under the dilation when you move the center? Well, it relocates that triangle. What happens if I make it closer or farther? Does the size change? No, the size of that green triangle stays the same, but the location moves. Here it says change the scale factor. If I make it 1/3, it made it smaller. 1/2 is also smaller. What if I made it 1? It lines up perfectly with the triangle. 2 is larger, and 3 is larger. So when the scale factor is less than 1, or smaller than 1, like 1/2 or 1/3, the image is smaller than the original. If the scale factor was equal to 1, what happens? The image is the same as the original. And if I make the scale factor larger than 1, like 2 or 3, the image is larger than the original. Change the center of dilation and scale factor to explore. How is drawing an image under a dilation similar to making a scale drawing? It appears that the size and the dilation in the scale drawing are the same, but the location of that center of dilation changes its location. The only difference is that location for the center of dilation changes its location. How is drawing an image under dilation different from making a scale drawing? In a scale drawing, we didn't have a center of dilation. And we didn't have the lines to create a scale drawing connecting the center of dilation and corners of the figure. Please make sure that your workbook is filled in with any notes for this lesson and that your warm-up is complete.